Okay. Good morning, everyone from Copenhagen, and warm welcome to all of you behind your screens to this first ever CLCplus Backbone webinar. I'm Manuel Mayr, and I'm with CLMS at the EEA, and I'm responsible for the implementation of the latest 2023 production of CLCplus Backbone on EEA's side. And today's webinar is all about Europe's still fairly new high accuracy land cover product, CLCplus Backbone, and what you can expect from it and how you can use it and access the data. Next slide, please. Yeah, but before we get started, some netiquette. This webinar will be recorded and made available afterwards via YouTube. I understand your cameras and your microphones are switched off by default in this webinar, but we will, of course, give you the floor for questions later on and unmute you as needed. If you have been following our previous CLMS webinars, you are already well aware that we use an app called Slido. First, for you to post your questions throughout the entire webinar, and second, also to collect your opinion on a small number of questions that we have prepared in advance. So feel free to scan the QR code at the bottom of the slide or enter the numbers manually to be prepared when it's time, and we will let you know. Next slide, please. So what have we planned for you today in the upcoming hour? We're already halfway through my introduction. You will then receive first-hand information from the implementing industry consortium about what CLCplus actually is, which products we offer for you, and also some insights how this data is actually produced. We have Fabian Berndt, who is the project manager from the consortium lead GAF, speaking about the operational CLCplus Backbone raster, and Inés Ruiz, sorry for my Spanish, who has been involved in the production ever since, speaking about the CLCplus Backbone vector product. We then switch the topic to focus on the usage and application of CLCplus Backbone. We have Benjamin Argyle-Ross from the consortium member GeoVille, who will inform you about the general and exemplary application areas of CLCplus Backbone and the product's strengths. Thereafter, we go to a concrete use case of CLCplus Backbone. We have Tobias Langanke, also from the European Environment Agency, to provide you with some insights how CLCplus Backbone is helping with him within the CLCplus framework to get a dedicated geospatial product that is even used for policy support. And in case the acronym LULUCF doesn't mean anything to you by now, you will certainly know afterwards. Then Benjamin will come back for another intervention to show different ways how you can access and exploit the data and the resources that we provide. After that, it's time for a Q&A. So it's time for your questions, and we'll try to answer them before I then will quickly summarize and close with an outlook of upcoming releases. Next slide, please. So to give you some background, Corinne and CLCplus, if you're into land cover monitoring or have been following the CLMS for a longer time, you very likely have heard about a product called Corinne Land Cover. And already during the 1980s, the need for harmonized land information was recognized. But yeah, times were different back then. And Copernicus, for example, was only known as a Polish astronomer and not associated with Earth observation. And as such, availability and access to satellite imagery were entirely different. And so were our means to produce geospatial data sets. And in a pioneering effort, the EEA, together with its national partners across Europe, these so-called IONET members, mapped the entire land cover and land use of Europe for the first time for the reference year 1990, with input data from over 12 years. And this Corinne land cover is still produced in a largely similar way nowadays, and it's offering a unique temporal record and unprecedented thematic detail of 44 land cover and the end-use classes. And you could say that good things stay and they develop further as do user needs and applications. And geospatial data sets and Earth observation are nowadays widely adopted across domains and even used to support policies. And technological progress, and especially Copernicus, have boosted Earth observation data and methodologies, I would say. And to cope with the associated needs, CLMS brought up the so-called CLCplus framework with the original idea to produce a next-generation Corinne land cover. And as you might have already noticed, the naming is kind of associated, the CLCplus. Well, we have to admit that the originally intended approach to produce a bottom-up, high-resolution pan-European land cover, Corinne-like land cover and land use product from a land cover product, a kind of backbone, that is also the name of this land cover product, and the harmonization of land use information from 38 different member state data sets that are all brought together in a common database, so-called CLCplus core, and harmonized there geometrically and then also semantically, has been proven very costly until today and also difficult. Still, as we will see today, CLCplus Backbone offers an excellent and highly automated land cover products, and the CLCplus framework is getting up to full speed to offer reliable and flexible geospatial information. Next slide, please. Here is a direct comparison of the CLCplus Backbone raster product to the left and the Corinne land cover to the right from the northern lakeshore of Lake Attersee in Austria. And as you can see, Corinne land cover's larger degree of generalization is a result of its minimum mapping unit of 25 hectares. And the high level of geometric detail of the land cover classes as contained by Backbone, that is also fully exploiting the potential of the underlying Sentinel-2 satellite imagery. So for instance, the Backbone to the left gives you a more differentiated view on the sealed areas, which are shown in red, and captures entirely new features and patterns of the landscape, such as smaller patches of vegetation and also smaller water bodies. And with this, I believe it's time to look a bit closer at CLCplus Backbone productions, and would pass on to Fabian, please.
Yes, thank you, Manuel, and also welcome from my side. I'm going to present the CLCplus Backbone raster product, starting with a general overview on the next slide. So the CLCplus Backbone is a gapless land cover classification product in raster format. It covers the whole of EA38 plus UK and the French overseas departments, with a small exception, which is that UK is not available for the reference year 21 due to its withdrawal from the EU, but it will be integrated in the upcoming 23 product again. So the product is available for 2018 and 2021 already, and as just mentioned, it will also soon be published for 23. And the main raster classification is accompanied by 3 auxiliary layers, being a data score layer, holding information on the available Sentinel scenes, the number of available scenes for the input time window. Then there's a confidence layer giving information about the confidence of the classifier in the class assignment for each pixel. And there's a post-processing layer flagging all areas that have been changed in the post-processing process. And all of those products are, of course, freely available to everyone. Next slide, please. The key technical specifications are the following. The coordinate reference system is the European ETRS 89 in La Haya projection, and the French overseas departments are available in the respective national projections, which are all WGS 84 UTM. The spatial resolution is 10 meter, and the minimum mapping unit is 1 pixel, so equivalent to 100 square meters. The accuracy requirements are 90% overall accuracy for the whole product, and 85% producer and user accuracy per class. And those classes are shown on the next slide. So we have 11 classes that are mapped following the eagle concept. Those classes are sealed areas, needle-leaf trees, broadleaf deciduous, and broadleaf evergreen trees. Then a rather complex class, low-growing woody plants comprising natural shrub formations, as well as hops plantations, berry plantations, vines. So that's pretty complex class. Then there's permanent herbaceous, periodically herbaceous, which is characterized by at least one bare soil event throughout the observation period. Lichens and mosses, non and sparsely vegetated, water, and last but not least, snow and ice. The class assignment is based on the predominant land cover within a 10-meter pixel. So actually, the basis for the class assignment is even sub-pixel information. And the class assignment is defined by a decision tree, which really gives clear guidelines so that every pixel can finally be assigned to a class. And there's just a small excerpt of the decision tree you can see here. So based on area shares, it is then decided which class it should finally be. On the next slide, we see the input data. So the backbone production is primarily based on Sentinel-2 time series data, which is covering the reference year plus minus 3 months. For 2018, it has still been plus minus 6 months, but that was reduced not less to just provide a product in a more timely manner. The time series includes all acquisitions that are available with a cloud cover of maximum 80%. And those images are then the input for an interpolation where the data is interpolated to 10-day intervals, so that for each pixel in the end, there are 54 time steps available for the classification. The utilized bands and indices are also displayed here. So there are 8 Sentinel-2 bands directly going into it, and 4 indices, also including the difference vegetation index, normalized difference water index, and yeah, Sentinel bands mostly in the infrared area and red and green. Then on the next slide, we see the second most important input data, which is the training data. So for the classification model training, we rely on a sample database of more than 1.1 million samples across the whole of Europe. Each sample point refers to its underlying 10-meter pixels and assigns one of those 11 classes to it. The sample database is reused in each subsequent production and updated based on a machine learning based detection of suspicious samples, which are flagged as potentially noisy or in conflict with the assigned class, and those are then revised by expert personnel and updated if needed. And next slide, please. Here, just a brief overview on the methodology. So the interpolated Sentinel-2 time series and the training data are the input for regionally calibrated classification models. The classifier used is a TEM-CNN, so a temporal convolutional neural network classifier. And the outcome of the actual classification are class probabilities, which are then going through several post-processing steps to come to the final class output then. And those post-processing also comprises a noise filtering, blending between production units, and also a calibration with the previous backbone products for consistency reasons. Then on the next slide, there are some changes shown since the first available product for 2018. So since then, the seawater areas in the coastal zone or beyond the coastline have since 21 been assigned to a separate technical class, just to enable more reliable water statistics also for countries with a significant coastline. And another change that has been or will be introduced, yeah, we see that on the next slide. Another change that will be introduced with the 23 product is a change in the data format. So for 2018 and 21, the product has been available as European-wide mosaics. And with the upcoming product, that will change to 100 by 100 kilometer tiles, which gives you as users actually the opportunity to have more targeted data requests. So like in this example, if one would be interested just in the city of Madrid and its surroundings, you would just have to request one tile and not the whole mosaic. Then on the next slide, and that's already my last one, you see a few examples from all over Europe. So on the lower left and the upper right, you see two different patterns of agricultural use. So on the lower left from Portugal, you see some circular arable fields here being irrigated areas. So that's a typical form here. And on the other hand, you see very different patterns from an example in Poland. Then on the lower right, we have the Bosporus with the city of Istanbul, showing nicely how large cities are represented. And you also see the very fine structures of the infrastructure around it. And then we have two examples from mountainous regions with glaciers. So on the upper left, an example from Norway. And then at the bottom, a very interesting examples showing the CLCplus Backbone timeline. So the products 2018, 21, and 23 for a glacier in Tyrol, actually one of the largest glaciers of Tyrol, the Hintereisferner, which is shrinking very fast. And you can nicely see that when you leverage the time series, especially the one tongue here in the, I actually can't use the laser pointer, sorry about that, but you can just see nicely how the glacier shrinks within those 5 years of the existing timeline, actually. So that's a nice example how you can use the timeline to visualize such things. Yeah, that's already it from my side, and I would hand over now to my colleague Inés Ruiz, who will present to you the vector product.
Yeah, hi everyone. So you can go right to the next slide, please. So the vector product, besides the raster product that you've seen that it has already a history within it and a future within it, there is also a CLCplus Backbone vector product. In this case, it is a one-time only done for 2018. And its concept is based mostly on identifying meaningful objects that have a spectral and or textural homogeneity over time. They have to be unique in comparison to their surroundings. So the emphasis is given to the geometric definition of these isolated in landscape objects, which are produced mostly based on Sentinel-2 imagery segmentation. The thematic of it is brought afterwards, so it's brought into the polygons, but coming from the raster product that has been presented by Fabian. So if you click, please, what was the aim and the concept for creating the vector backbone? So the first idea was to have a standalone and specially detailed geometric base for the rest of the CLCplus suite of products. so the core and the instances that Manuel has presented and that you will see some examples from Tobias. The second one was to have exactly these land cover units homogeneous on its sense, so not purely thematic based, but homogeneous using the Eagle terminology. To have a useful product that could help enhancing the priority areas monitoring of the CLMS as well, so as a basis for the different vector products on the CLMS. And for the moment, up to my knowledge, there are no updates planned on it. So if you go to the next one, please. So how is the product created? So the first thing is the collection of input data to create the first skeleton, which is done by combining mostly linear infrastructure, so hydrological and transportation network. And if you click, you can see the examples, what I mean. This data is coming mostly from different data sources, be it national, regional, global, European, and then it's complemented by artificial extraction on VHR data. It creates this hard bone, which is a binding skeleton to the soft bone. So what is a soft bone? The soft bone is this Sentinel-2 segmentation-based process that extracts the spectral homogeneity on a pixel-based level, and it's carved into the hard bone. As it looks a bit pixel-based, then it's smooth to have a more natural look and feel to create a very final backbone, which is this empty geometry of continuous polygon covering the whole territory, in this case, the EEA 38 plus UK. So if you go to the next slide, please. As I mentioned, we will have these landscape objects that are coming from Earth observation and in situ data. And together with the raster product presented by Fabi, we create the vector product. So what does the vector product finally looks like? Can you go to the next one, please? We have a nomenclature of 18 classes compared to the 11 one coming from the raster. And it's kind of an aggregated product because, of course, it's carving into the landscape object geometries, the thematic land cover information coming from the raster. So because of having a lot of classes or potentially a lot of classes on every polygon that could not reach maybe the 50% of the class assignment, this assignment is done in a hierarchical way based on a decision tree as well, oriented along the Eagle matrix. If you go to the next one, you'll see that because of this, there is a lot of information on every polygon that does not include only this land class of the 18 classes. It has much more than that. You can see, for example, at class level, the first 3 dominant raster classes. So not only what they are, of course, the code of the final vector class, but also the raster class is dominant on each one and the percentage of each covering the area of the polygon. So this can be used for drafting some statistics on it. And if you go to the next one, you can also see that not only those classes are seen in these vector polygons, you can also see a lot of attribution that comes from other products, be it CLMS, like riparian, coastal, urban, DHRL, forest with the tree cover density or imperviousness density as well. But it also has the FEs coming from the emergency service. It also has elevation information coming from the Copernicus dam. So it has a lot of additional information per polygon. So some examples coming to the next slide. And if you click already in this area of Luxembourg, you can see this small polygon where you can see that the land cover code of the 18 classes is the 12, so high ceiling degree, between 50 and 80% of the polygon covered. And if you see the DRCL 1, 2, and 3, you can see that the first one is the sealed area coming from the raster and covering around 75% of the polygon. You can also see the second one being permanent herbaceous, covering around 20%, and you can see the third one, be it broadleaf deciduous, covering around 5%. So some other example, a bit different in Hungary. In the next slide, please. You can see as well a small polygon that shows that it's code 53, so permanent herbaceous with many trees that should have more than 30 and 50% of between 30 and 50% of trees. So if you check a bit, you can see that the first land cover coming from raster is 6, which is this broadleaf, this permanent herbaceous, if I remember correctly, yes. And the second one is class 3, which is broadleaf deciduous with around 30%, and the third one is shrubs with around 15%. So some more general things that you can see if you go to the next slide, please. This is an overview of the bordering area of Hungary with Slovakia and Romania, a big area, where you can see on this slide some example on how it would look, all the polygons, if you zoom out, of course, with all the classes. This is a show of the 18 classes of the vector. But if you click, you can also see that you can see the vector in a different way. So you can analyze it from its attribution, and you can see, for example, in this case, the mean tree cover density per polygon. And if you go to the next one, you can do exactly the same, but based on the mean object height above sea level for the whole area covered, so per polygon and per area. And I know it's short, but this is a product that was not meant to be renewed as the raster. It's a completely different approach. It is not as you have other products like the priority areas monitoring, which are normally manual and visual extraction. So it's a purely automatic process that has to be expected to be like that. It's not a manual one. So it is a bit different. It is more difficult to be used. I understand that, but we are here to answer any questions you might have on that. And with that, I finished my presentation, but I would like to, if you go to the next slide, please, to tell you that you can go to Slido now. If some of you have joined while we were presenting, you also have here the QR that you can scan and go to it. And we have there the first question for you. So it is, when using land cover data, which are your biggest challenges with regards to your intended use? So we will give you some seconds to answer that before we move on. And thanks a lot for hearing me.
Thank you, Ines, and also Fabian before. I can see that oh no, I actually cannot see. I thought I see some early results here in the Slido, but I'm sure we have it collected, and we will also provide it to you, all of you, afterwards, the results. And I think we have already over 30 people participating in this poll. We wait a couple more seconds, and then I would hand over to Benjamin. Okay, we have 50 people participating in the poll. That is really great. It seems to be a rather stable number now. No, it's still growing, moving up to 55. But in the interest of time, I would still say we continue now with Benjamin, please.
Sounds good. Yeah, thank you very much, Manuel. So I'm Benjamin. I'll be briefly introducing certain applications and potential use cases of the Backbone project. If you can move to the next slide. Oh, seem to have skipped ahead slightly. All right, we seem to be missing a couple of slides, not to worry. So we actually have here a good first visual example of how the Backbone can be used. Fabian's already gone through a few potential areas, some visual examples of how the Backbone can be visualized. But here's also a really good example in Bucharest, just in Romania. Here you can actually see the completion of the ring road just outside of the city. And actually using it in conjunction with the satellite images we have here from Google, you can see the change between the vegetated state and the sealed. That's here represented with the Backbone. Can we move to the next slide? Okay, this was the slide I was waiting for. So there are actually quite a few benefits to the wall-to-wall coverage of Backbone. Wall-to-wall being the coverage of a certain geographical area with no data gaps or missing data. So in the Backbone's case, as we've already mentioned, this covers the EEA 38 plus the UK and the French Overseas Department. We've highlighted here handful of different benefits for the specific use of Backbone. Here we can see, for example, with use of the Backbone, we have a great holistic view of the entire land surface of the EEA 38 region, as an example. This gives a very consistent overview of how the land cover is used. Next, we have the interrelationship analysis between the different land cover types. Oh, no, sorry, not done yet. We have the interrelationship analysis of the different land cover types. This, for example, you can use Backbone to distinguish between environmental monitoring, for example, urban planning, agriculture and forestry. We also then segue nicely into the seamless integration with other data sets. Backbone, as the name suggests, can be used as the backbone to other data sets. It's a great foundation to build upon other projects, use it as a foundation of how land cover is represented throughout Europe. We can move to the next slide. Thank you. So we highlighted just a handful of more specific application areas. So here, for example, we have environmental monitoring, as mentioned earlier. So a great use of the Backbone, for example, would be habitat assessment. We can use the Backbone to assess where certain habitats are located, assess their health, and the biodiversity within the area and surrounding areas to make sure that any protected areas can stay protected. Next, we have climate change studies. A good example here is the climate adaptation. The use of urban heat island studies, for example, will greatly benefit from the use of the Backbone project. For example, the analysis of land cover on local temperatures and the then subsequent development of potential strategies to adapt to these changes. Lastly, we have the research and educational use. The Backbone is perhaps a really good entry point for those who are interested in Earth observation and land cover in general, as it provides, as mentioned before, this more holistic view of land cover. The Backbone, from our perspective at least, is a great first entry point for those who are interested in land cover. I believe that's it from this section. I think next we have a Slido question, if we move to next. Yeah, so next up, the Slido question again, if anyone's joined late, please feel free to scan. This question is, if you were to use the Backbone project, what would be your main application? We'll give you a few seconds again to fill this in. All right, I think next up we have Tobias, who'll be introducing the LULUCF use case.
Yes, thank you, Benjamin. So Manuel promised that I would explain what LULUCF is for those of you who are not used to European abbreviations. So that stands for land use change and forestry, and is one of the more important and increasingly important sectors for greenhouse gas reporting. So I have been implementing CLCplus and other products for the land service at EA, but in the last few years have shifted to the climate program, and I'm now based in the reporting and greenhouse gas reporting and verification unit on the climate side. So I'm trying to link the Earth observation-based production in the Copernicus side with the climate use case. And again, as I said, LULUCF sector is important for various reasons. It is, if you switch to the next slide, it is the only sector that can actually take CO2 out of the atmosphere, and is therefore sort of crucial for reaching the EU's ambitious targets for climate neutrality. And so the improvement of monitoring that sector is recognized as crucial on EU level, and that is sort of reflected in the legislation that is behind this, the LULUCF regulation and governance regulation here. No need to go into details, but I just highlighted in red some of the elements that specifically mention enhanced geospatial data use, remote sensing use, and Copernicus. So this is crucial to understand. The need for doing this to supplement existing approaches has trickled down even to the level of the actual regulation itself. If you go to the next slide. I have to stay a little bit superficial, but I have one slide at least to show you what the countries report under LULUCF. It's actually not maps that they report. It's not geospatial data. It's tables that they report every year. And they report basically 6 main land use categories: forest, cropland, grassland, wetland, settlement that are listed here. So they report in tabular form the area estimate for that year. And then basically the greenhouse gas emissions and removals are estimated from that area calculations using so-called emission factors. So again, I can't go into detail here, but this is a relatively a sort of rough way to estimate things. But this is what we're dealing with here. And the ambition is that the monitoring that is behind these tables is going to be improved by increasing use of geospatial data. So we will continue not to get geospatial data from the countries, but the reporting will remain in these tables. But we simply want to make sure that we sort of improve the quality of the reporting and the data that is behind these tables. If you go to the next slide, thanks. So how we do this is, again, we create a specific product to support LULUCF, the so-called LULUCF instance. And that is a geospatial data set that gives us a country data independent proxy for what the countries are reporting. So we're trying to map the same thing that the countries report in these tables. Green land cover here on the left, just to be complete, is continued, but the CLCplus system is where we are actually producing the LULUCF instance. Backbone and other data goes into CLCplus core, the database and online system, and we are then combining that existing data in these LULUCF instances. So these are 100-meter products. We don't touch satellite imagery. Again, we use existing Copernicus and other data sets to do this. Just to be complete here, you and everyone can also directly use either, of course, the backbone data that we've heard a lot about today, but also CLCplus core as a web application can be used. You only need to get an INET password. You can contact us if you have interest in exploring that system itself. So in principle, that's open as well. If you go to the next slide. So a lot of data goes in that's listed on the left side. I highlighted in red the backbone data, which is the most important data set. All of this is sort of inputted into the CLCplus core. We call that process ingestion, and harmonization is done to one sort of language, one common nomenclature that we use in that system, which is called Eagle. Again, the time is too short to explain this, but just to say that this is a standardization and harmonization model that allows us to work together with a lot of different data sets. And then we combine all that information that we then have in the system in specific ways to get the classes that you see on the right-hand side. So we are creating rule sets how to combine the existing information. And this is all documented, of course, in the system as well, and could also be used by other users and modified with their own data sets. Next slide. Just to show you visually how that looks like. So this is the product we had for 21. Please note that from 21 onwards, we will extend the area to the full EA 38 plus UK area. So and this is not to show any sort of specifics in terms of content, but just to show that this data set on the right-hand side, we see a little zoom in southern France, where you can see that we also get some categories. But of course, this is 100-meter data. So if you were to zoom in even further, you would realize, of course, that the 10-meter backbone data is of a higher spatial resolution than this data set. But in terms of the use case, the actual use case now, so what I'm now doing with this data, and this is being piloted this year, so I'm in the middle of this, I'm basically also creating a table like the one that the countries submit every year with the same categories, but estimated from our LULUCF instance data set, and then compare this to what the countries report for the same year. And so the whole idea would be to identify categories and countries where we have significant differences that cannot be easily explained by known factors, right? That might point to room for improvement somewhere. And then initiate a sort of exchange with the country to get to the bottom of this. In many cases, it will actually turn out that we have gaps in our data, so that the problem is sort of caused by insufficient information that we have in our mapping. Many countries have, of course, very good national data. But in some cases, we hope that it's also possible to establish room for improvement on countryside, which would be the whole aim of this whole exercise, right? So that we add to the existing checking mechanisms that are in place for these greenhouse gas reported figures, the so-called initial checks. For those of you who are in the field, these continue as they were, and this is not replacing any existing checks. This is adding an additional thematic option that we have to look at the content of the data that is delivered by the countries. And again, the take-home message is what we want to do with this is help in the process of improving the quality of the greenhouse gas inventories. And again, this is the key sector, because as emissions go down in the industry and so on, this is a sector that will balance, by removing CO2 out of the atmosphere, that will balance remaining emissions in the end. And so it is a very good and very important sort of aim to have as good as possible a monitoring in place for that sector. I have one last slide to make sure I'm in time, sort of on the advantages of using actual CLCplus Backbone as an input data set here. These are more or less the same that were mentioned already, so I won't repeat them there around the high quality, the relatively frequent updates. Ideally, of course, we would have annual updates, but every second year is also quite good for our purpose. And we have this wall-to-wall product that was described also by Benjamin. I will mention before I close just 3 challenges briefly to be sort of a little bit more slightly self-critical here as well. So one of the challenges we have as we move to policy use cases for Copernicus data, those policy use cases often have very tight and repeated deadlines, and also in this case. So that is a challenge that the production needs to be really precisely in time for these deadlines. We also have looking into how reliable and consistent the change signal is that is inherent in these status layers, at least in aggregated fashion on country level. So we assume that country statistical changes in different status reference years for Backbone will actually reflect real change to a degree that is useful for our purpose. So this is still a little bit a question that we are looking into. And in general, the last one is maybe one of the most critical parts. We are working with land cover as a proxy for land use, right? So in many cases, there are limits to what we can do here. So land use forest is different than land use cover, land cover, tree cover. And so this is something we're struggling with, but there's no easy fix for this, except to say that improvement in land use data is high on our agenda still. So that would be a very, very quick glimpse into this European use case from my side. Thank you.
Thank you, Tobias. And also Benjamin, you're now back with another part. Sorry.
Yes, I am. Yeah, thank you very much, Tobias. Yes, so now I'll just quickly go through how you can access the Backbone data. If we could move to the next slide. Thank you. So there are three main methods on how you can use gain access to the Backbone data. I'll go through each briefly here. If we could move to the first one, which will be the EEA CLMS portal. Can we move to the next slide? Thank you. So this will probably be the main entry point for you when it comes to accessing the Backbone. This is the CLMS portal. Here you get a very wide overview of the product. You also have access to technical specifications, key documentation, and you also have access, maybe most interestingly, to the map feature. Here you can actually view the Backbone, currently the 2018 and 2021 products only, but you can upload it to the portal and have a look, and you can also use it in interaction with other CLMS products there too. The next entry point is via Wikio. This is perhaps a little bit more technical in terms of access point. It allows you to do data processing basically in the cloud. It's actually a fantastic place to combine the Backbone dataset with other datasets too. It's also worth mentioning here that the ancillary data, which Fabian mentioned during his presentation, that's the data score layer, the confidence layer, and the post-processing layer. They're also available to download here. They're not visualized, but they are available to download. And lastly, we have the GeoServer. This is quite a highly versatile entry point. And again, it can be used to integrate with other web applications using the WMS. Yeah, this is a great way to request specific Backbone imagery data. And lastly, if we move to the next slide, as I've briefly mentioned before, in terms of the portal, there's some key documentation here which is available. Most importantly, the product user manual and the algorithm theoretical basis document, or ATBD. It's probably a little easier to say. These aren't available at the moment for 2023, but will be made available soon. And as mentioned, they are available via the CLMS portal. And that concludes my part of the presentation. I believe next we have another Slido question. If you get your phones ready. So the last question, I believe, for today, what type of additional support would be most beneficial for you in terms of improving the land cover assessment capabilities using CLCplus?
So thank you, Benjamin. I believe we have already over 50 participants for this question here. Maybe one addition to what Benjamin said, if you're now searching for the PUM and ATBD of the 2023 update of CLCplus Backbone, sorry, it is not yet available on the webpage, but it will be made available in May. As will also be the 2023 update of CLCplus Backbone raster. And I believe it's now time for a Q&A. So thanks, first of all, for all of your questions. We have got over 33 questions, and I'm afraid we cannot answer all of them within the couple of minutes. But I would like to start with the most popular one. So there's a possibility for you to upvote the questions that were already posted in the Slido, where you can also type in your questions now right away. So the most prominent question is about the training data set, actually. So how are the 1.1 million training points gathered? Are they validated? Are they being made public available? And this is obviously an interesting question. I can say, first of all, on the last part of the question, there are currently no plans to make them publicly available. But I would maybe ask Fabian to give us some further insights on how the training points are actually gathered and if they are validated.
Yes. So first of all, those training points were actually created for the 2018 production. As I said, they're reused in each of the subsequent productions. In the first place, they were actually consisting of several data sources. On the one hand, Luca's 2018 data was used, where there was a filtering applied to really get to points that are usable for the CLCplus Backbone nomenclature and really with a high certainty and represent the classes. Then there were also points collected actually manually by expert personnel, by regional experts, really with a large consortium of companies being involved there and really looking at VHR data and collecting points for the 11 classes. And other data sets that were used were national land cover data sets wherever available. That's certainly a topic that's not so easy. So there is not too much out there which is freely available to be used here, but whatever was available at that time was also used. So the data that's collected there for the training, I would say it's validated in that sense that the input data used is validated on the one hand, and on the other hand, with the updates we do with each production, we are specifically searching for outliers that are then revisited, and again, actually expert personnel is having a look at it and is somehow confirming or updating the land cover code. So that's what's been done so far on the data. I hope that answers the question.
Thank you, Fabian. I believe it does. There's unfortunately no possibility in Slido to approve from the person who had asked it, but I think we can conclude that the training data set used for the production of CLCplus Backbone is certainly high quality and also made with a tremendous amount of manual intervention. The next question I would like to post here, because it's now equally high rated as the previous question, is the accuracy of the changes between 18 and 21 validated? And I might go ahead and answer this myself. As we have presented to you, the data set CLCplus Backbone is status-only data. So what we do not provide a dedicated change layer here. As such, there is no validation of a change layer. There are obvious quality control processes in place, that being the internal verification done by the production consortium. And also we have validated both 2018 and 2021 raster status layers in an independent validation. And these reports are also about to be published. They are actually the first of their kind from our new validation framework. And what I can also make you aware of is that we are actually looking specifically at this topic, that we don't really have a change layer in place, but still we're running a usability assessment, as we call it, later this year to really assess the consistency of the status layers. of the entire time series that we have in place then. And I believe from a production side, there is also, of course, a process in the production that is the interannual calibration. So the consistency is actually considered and then also partly, correct me if I'm wrong, Fabian, partly manually assessed between the years if an update is actually correct in the real world. And Fabian, would you like to add anything else to that?
Yeah, I mean the most important point for the interannual calibration, how we call it, is maybe that really we're leveraging the whole time series, and the class probabilities for each year are used to really search or to really allow changes in the land cover products where there's a really high difference in the class probabilities. And so from a certain degree onwards, we allow the changes. And if class probabilities are within a certain range consistent, then the land cover classification will stay consistent. And in that way, we get to really a stable time series, but still allow for changes where there's a high probability that there has really been a real world land cover change. So that's what's done during production.
Okay, thank you, Fabian. So we will go ahead with the next question, and that is actually related to a suggested use that we have proposed. So the question is the thematic detail of CLCplus Backbone sufficient to use it for habitat assessments? Can you say more about it? So my first guess would be certainly it can support habitat assessments, maybe not of all habitats. Probably it is also up to the definition of the habitat that you would like to assess. But I believe land cover data and also the detail of thematic classes that we provide here can assist you certainly in habitat assessments. I'm not claiming that CLCplus Backbone is specifically designed to serve as the primary input for habitat assessment, but I believe especially at the European scale, it could be helpful to assist you, and probably also on other spatial scales. Then there is another question on the LULUCF land use classes of the instance, the maps. Tobias, will they be made publicly available? Are there any plans?
Yes, indeed. I'm working on this together with the CLMS team. It will likely be just after summer. They are in principle available already now on request, so you can send me an email and I will immediately make them available. We were holding back a little bit, largely because we are combining existing information and we want to avoid that users misunderstand the data as providing new and additional information. For example, we have a relatively little wetland, good wetland information in there, and we want to avoid users looking at the fact that we publish now an annual wetland component in that instance, and then simply assume, CLMS is doing now a wetland mapping every year. Let's use that. So this is a little bit the sort of the concern we had, and we will have to be a little bit extra careful in sort of presenting the data on the CLMS portal. But it's ongoing, will be after summer, and if you want to have a look before that, just contact me and I'll make it available.
Thanks, Tobias. So I believe we have, we are already over time, but I hope it is okay if we answer one or two more questions actually. And one of them would be, for example, on the CLCplus Backbone land cover classes, are you planning at synchronizing these land classes with other existing land cover products, for instance, using types like agriculture? Maybe I answer that or try to answer it. It's certainly a very difficult and frequently asked question. For once, I would say we're doing our best to be very transparent about the class definitions that we use for CLCplus Backbone, and the name Eagle has been often been named in this webinar already. So this is really the how do you say, the semantic system that we have in back there, and it is actually designed to allow actually through a process called barcoding also to ensure a land and class characterization that also in theory allows you to compare different nomenclatures. But this is of course always a case-by-case decision. And for the type agriculture, I believe this is very difficult because we're working with land cover here. I personally regard agriculture certainly as a land use more, and it can be very diverse. If you think, for example, on croplands, we also have dedicated products for that, versus, for example, livestock farming, which is usually grassland. So agriculture in general, we are aware, is a topic that we cannot fully exploit with land cover only at this stage, I would say, at least with CLCplus Backbone product. And maybe as a last question, there has been a question on the plans for the release for another CLMS product, and that is the high-resolution water layer and water cover duration. This is certainly not really under the consortiums and my responsibility here, but I was quickly cross-checking with the responsible product owner at EA, and I can inform you that first products, being the yearly and the multi-yearly, will be made available after the summer of this year. And with that, I believe we are already almost at the end of this webinar. Maybe another question that popped up and is frequently demanded by the other users is, will the slides be made available? Yes, we can make them available as PDFs, of course. And yeah, if you allow me a quick summary and an outlook. Next slide, please. So we have seen that CLCplus Backbone is actually Europe's high-resolution land cover product, and it is actually not only producing data for the EU27, but actually beyond, also for example, countries like Turkey or Iceland, Norway, Switzerland, the Balkan countries. So it really has a tremendous continental coverage. It provides a consistent and high accuracy information source that is nowadays updated every 2 years. And as we have seen, it facilitates diverse applications and different domains. And of course, we are happy to hear also about how you use this data set and which experiences you have made. And as a last thing, upcoming, I mentioned it already before, we have planned the CLCplus Backbone 2023 production to be published in May, and also the first validation reports of the 2018 and the 21 productions. Furthermore, we will have CLCplus Backbone production planned to be published in 27, and that is the 2025 reference year. So if you're now interested in the product, please use the QR code to the right, and you will be directly pointed to the production or the product web page on the CLMS portal, and you can get further info there. And yeah, with that, I would like to thank you, the audience, for your participation. I would like to thank all of our speakers and also the non-visible colleagues in the background who facilitated this webinar. I wish you all a happy Easter and hope to see you next time in a CLMS webinar. Thank you and goodbye.